Hey guys, it's Mr. Dugal, and today I'm going to help you identify whether you have linear growth present or exponential growth present just by looking at a table or a graph. Uh, First of all, just really quickly, looking at our graphs, if we have a parabola present, a parabola is a curved line. In terms of your equation, rather than having y equals mx plus b, you're going to likely have something like y equals an x squared plus or minus something, or x squared plus 3x minus 4. Usually there's some type of exponent involved with the variable with a parabola. This is exponential growth. This is a curved line. It is not linear, and it goes up or down very rapidly. Linear growth, one really super obvious way to tell if you have linear growth is if it's a line. Linear has the word line in it. If it's a line, it's linear growth. In this case, it would follow some type of y equals mx plus b, where the slope, it's decreasing, so we know our slope would be negative, and it looks like our y-intercept's up a bit. This would be a positive y-intercept because it's up. So that's linear growth compared to exponential growth just by looking at a graph. Over here, we have increases going on from one to the other, and overall, we'll notice that our x is not going up by 1, and that we don't start at 0. So this would be present, we'd have a y-intercept present in this one. But we do notice that for each one, it's going up 6 for y, and it's going up 2 for x. And so that basically our growth is, the change in y is 6 compared to a change in x being 2. So our slope here would be 3. Because we have a slope, it is linear. And from there we could actually figure out what our y-intercept is. We'd go back 6. For every 2 we go back this way. So thinking about that, we'd go back 30. So our y-intercept would be negative 26. And that's because if we're going back 10 in the x to get to 0, we'd have to go back 3 times that amount in the y. And so basically if this was minus 10, 10 minus 10 is 0 for x. And if this was minus 30, 3 times the 10, it'd be 4 minus 30, y would be negative 26 when x is 0. So there you go. This would follow a line to be y equals 3x minus 26. This is certainly linear. On the right hand side, you'll notice that we're going up again 2. So the first time we're going up by 72 on the right side. 108 plus 72 would be 180. That's not true. So my next number is not 180. So it is not linear. It does not have the same slope. In other words, it's not increasing by the same rate for y that it is x. As a matter of fact, it's increasing much more. This time it's increasing by 216. Exponential growth is going to involve some type of exact multiplier. Exponential growth involves multiplying when we're going vertically, versus linear growth is an addition when we go vertically. So we can see 72 times 3 is 216. So our next growth is going to be 216 times 3. 216 times 3 is 648. And that's correct. 324 plus 648 does equal 972. This would be exponential growth. And the equation would follow some form of x squared and x. So exponential growth, basically on our 2 examples here, exponential growth is in the blue. So this is our exponential growth, and this is our exponential growth, and the linear likewise is in red. The graphs don't necessarily follow the tables. These are just examples of how you can tell linear and exponential growth by looking at a table, and then separately how you can tell linear versus exponential growth by looking at a different graph. One more thing I wanted to point out is just the differences in exponential growth from when we have an increase to when we have a decrease. On the table, you'll notice the increase. Basically, as the x's increase, our gaps get even larger, and you can imagine just how large these numbers would get if we keep multiplying by 3. Basically, the y's will increase very rapidly while the x's are still only increasing minimally. When we have a decreasing parabola, decreasing exponential growth, the opposite is true. A good example with this is in biology. There is something called a half-life, and a half-life involves an element or a compound. So basically, if the half-life of an element or compound occurs, we'll say every 2 minutes, we'll use, so say that we have 980 milliliters of whatever the half-life is, and it occurs every 2 minutes. This means the amount of substance will be cut in half every 2 minutes. So the first time our decrease is 490. After 2 more minutes, it's cut in half again. And so we're at 245. So instead of our gaps growing, they're decreasing really rapidly. So divide by 2 instead of multiply by 2. So again, the gap between the two isn't going to be 245 this time. It's going to be half that much. So half of 245 is 122.5. So at 6 minutes, there's only 122.5 milliliters of that substance left, and so forth. So you can see that the decreases are going to be a lot less rapid as they come. So basically, the changes in y start to taper off as the x's go along. Whereas with an increasing exponential growth, the opposite is true. As the x's increase, the y's gaps start to grow even more large. So that's how you can tell linear growth from exponential growth just by glancing at a table or a graph. Hopefully this is helpful moving forward. Thanks so much for watching.